In the previous video, we learned lamis theorem, the statement we learned, and the conditions to apply lamis theorem, and how should be the force, and those all things we learned. And now let's learn the proof of the lamis theorem. Exactly the same figure I'm saying here. Once again, let me tell you, the lamis theorem says that if three forces which are coplanar, non-collinear, and concurrent and are in equilibrium, then that time each forces is proportional to the sine of the angle of the opposite two forces. All right, so if I'm talking about the force P, then the opposite two forces are this Q and R, so it will be in proportion with sine of the angle of this angle, which is beta. So P over sine beta. Similarly, Q over sine R, R over sine. So this we're going to prove. Okay, so our figure was something like this. You can make any kind of, so let's say this is A, this is B, this is C, and here A, B, C represents the forces which are coplanar, concurrent, and non-linear. Right, so let me suppose for a while that the angle opposite to the force A is alpha, and angle opposite to the force B is, let's say, beta, and angle opposite to the force C is, let's say, gamma. All right, so I'm going to make a little drawing here, little construction over here. I'm going to extend this B a little more, let's say up to here. All right, and I'm going to shift this A exactly parallel to this right here. It should be pretty straight, pretty parallel. This is A, force A. Now let's talk about the angle. Since this is a straight line and this is alpha, so this must be 180 minus alpha. And now see, this is beta and these two are parallel, right? Keep in mind. So by corresponding angle, this will be also beta. So this must be 180 minus beta. If you expand this a little further, and then this gamma and this angle will be also gamma by the corresponding angle. So this angle will be 180 minus gamma. All right. Oh my God. Let me write it with this color. All right. This is 180 minus gamma. So we got all the angle, inner angle of the triangle. All right, and before proceeding, I just want to take you to the sine rule that we have learned. Sine rule says that if this is side A, side B, side C, let's say angle A, angle C, angle B, then sine rule says that if I'm taking any side A, then this is proportional to the opposite angle, sine of the opposite angle A. If I'm taking side B, then it is proportional to the opposite sine of the angle this B, this B, sine of the B. If I'm taking the side C, then this is proportional to the sine of the angle C, sine of the angle C. This is sine rule in very short, I told you. And now exactly this concept I'm going to follow for this little triangle we have here. All right, so applying sine rule in a verb triangle, so force A is directly proportional to the sine of opposite angle is this one, 180 minus alpha. 180 minus alpha. And now let's talk about another one. Let's say we are talking about this side B. All right, so force B divided by this will be proportional to this one, and this is 180 minus B, so it will be sine of 180 minus B. All right, and let's talk about the last one, that is C. All right, and the opposite of this is this one, which is 180 minus gamma. So it will be C, for C divided by sine 180 minus gamma. All right, now I just want to tell you that sine 180 minus theta equals to sine theta. You should know this formula, because if you know the CAST rule, CAST rule, according to that, CAST, sine and cosec are positive here. So 180 minus theta, this is no change region. All right, 180 minus theta means you are in the second quadrant, and in second quadrant sine is positive, so it's positive, and this is no changing region. If you're adding or subtracting in the basis of this 0 degree or 180 degree, 180 degree, then that time this will be, the ratio will be same. So sine 180 minus theta is sine theta. All right, and if I'm using that concept over here, then what I'm going to get, can you guess? Yes, I'm going to get A over sine alpha equals to B over sine beta equals to C over sine gamma. And this is the lamis theorem. All right, isn't this? This is A and opposite angle is alpha. This is B and opposite angle is beta. And this is C and opposite angle is gamma, where A, B, C are coplanar, nonlinear, and concurrent forces. So this is how we have to prove the lamis theorem. I just explained here, but I would suggest you go write step by step everything that I did with my mouth, but you have to write in the notebook while proving. All right, so I'll see you in the next video with next concept. Till that time, bye bye.